In this webinar, we'll be exploring legacy modernization. We'll see how new design styles like APIs, microservices, and event-driven architecture can be leveraged to help businesses transform their older monolithic systems. But what's a monolith? Are we talking about the mysterious space-age monuments popping up around the world? Well, no. Software monoliths are just a little less sci-fi than that. In software theory, a monolith is a classical application architecture pattern. This approach consolidates code and dependencies into a single vertical stack. It's self-contained and non-distributed. Although having everything in a single silo may seem simpler, easier to manage, and easier to deploy, moving around this massive object becomes pretty cumbersome. Scalability suffers too, and deployments are difficult if you're updating everything all at once. Also, since everything is connected, small bugs could have a disproportionately large impact. So microservices, on the other hand, break apart software into smaller segments that are more decoupled and distributed. Arguably, this pattern is more appropriate to the needs of today's software environments because companies are quite decomposed, they're made of small components. Various teams have different types of software stacks, releasing to various client types on different timelines, and all the while adopting continuous delivery and deployment for better agility. So building these niche client-agnostic services means you could also reuse them throughout an organization in different contexts, especially if they are built with a standard interface for externalization. Breaking apart the monolith with microservices is a trendy concept, no doubt, and a lot has already been said on the topic. But as enterprises are realizing, microservices do bring unintended caveats. For one, how can architects manage the additional complexity of microservices? Should all monolithic systems be broken apart? What scenarios necessitate this sort of drastic change? And for when it is necessary, how do we break the monolith and not your business? So in this hour-long event, we're bringing together a couple experts, Erik Wilde, digital catalyst at Axway, and Gibson Nascimento, head of solutions at Sensedia. We're going to be presenting tips and best practices for utilizing microservices as a tool to smartly expose legacy applications as APIs. So as you can see with the agenda here, we'll be doing back-to-back lightning talks, followed by a group Q&A session. So please think about what you want to ask and comment in your questions, and we're going to answer them all in the Q&A session after the two sessions. So our first speaker, like I said, is Erik. I'm very happy to introduce him. Erik focuses on technologies, standards, and design issues of open service landscapes. His areas of interest include Internet and Web of Things, semantic technologies, service description and documentation, and questions of how to design for openness and evolvability. Erik is a frequent speaker at key events, including Nordic APIs, where he's spoken at multiple summits. He's also very active online, discussing API theory and video tutorials, and helping guide the emergence of new web standards. So yeah, honored to bring you back, Erik, and feel free to pull up your slides.
Okay, I'll do that. Thank you very much for the intro. So share my screen, share this. Okay, I'm guessing you can see my screen.
Looks good to me.
Okay, great. So thanks a lot for the introduction, Bill, and I'm really happy to be here. So let's talk about monolith modernization with APIs and microservices. What I want to talk about today is a specific way how you can go through a modernization process. The idea being that once you've decided that some aspect of what you're doing needs modernization, how can you go forward with it, and also go forward with it in a way that is not too risky and not too expensive, trying to minimize the number of changes you have to do and giving you the ability to only change those things that need to be changed. And what we'll look at today is a relatively simple pattern of how you can do that. and it's called the Strangler pattern. And what I want to do today is briefly talk about why you might even want to do it. It shouldn't be something that you just do because others are doing it. You should think about why you're doing it. And then I want to tell you an easy way how to think about the Strangler pattern and the steps it involves, so that you can start looking at it and maybe use that pattern to go through your modernization process in a controlled way, so to speak. Very briefly about myself, like Bill said, I have been a frequent speaker at API events. I still am, but of course nowadays, for the last almost a year now, most of them have been, all of them have been virtual. So I have channeled some of my energy into creating videos. If you're interested in API videos, check them out. I've linked the channel from my slide. And by the way, all my slides are online. If you go to my timeline on Twitter, you will see that my last tweet has a link to an online version of the slides, and you can just follow along. And I will also have some links in the slides, so that might be helpful. My background, very briefly, I work at Axway. Axway is a software company. We're selling API management software and some other things in the general integration space. I'm part of a small team that's called the Catalysts, and our mission is to help customers to do the right things with APIs. It's a kind of a very simple mission, but also can be demanding. Our goal is really to not talk about our products, but to make sure that our customers do the right things with those products. And that sometimes can be a little bit more demanding than just focusing on products, because then it's all about strategy and having the right plan, focusing on the right things and so forth. And modernization, of course, often ranks pretty high on the list of what people want to do. So why modernization? That's the question you can ask yourself. It shouldn't be something that you just do because everybody does it. And speaking to large organizations, what we found is there are two main sets of reasons that emerge. One of these sets of reasons are more kind of a bottom-up motivation, I would say. And these often are originating from more the IT side of things, where there's the realization that a monolithic structure can have, for example, scalability issues, meaning that if you have a very large code base and you have spiking demand for parts of your services landscape, scaling up that very large code base can become very demanding or just very expensive. And then the question is, can we do better than that and only scale those parts that need to be scaled? So in that case, the modernization drive really is originating in operational concerns, meaning that if you modernize, you'll be able to better match demand, better adjust to changing demand, and so forth. And microservices with containers, and in particular with models such as Kubernetes or serverless, are a good match for that. So the question then is, how do I get to that point where I can actually use microservices and get the gains of that approach that everybody is talking about? So that's the one motivation that we hear for why people do modernization. The other motivation that we often hear is a little bit more top-down, I would say, coming more from the business side, saying that the monolithic code base that we have too much represents what we've been doing in the past, and it's too hard for us to change that easily so that we can change what we do with our IT infrastructure keeping up with us. So the typical driver here is scenarios where the business side wants to change things, and then from the IT side, you're realizing, oh, that is really hard to do because it's a complicated code base that we have to work with, and changing anything is a very hard process. So in that case, modernization drive comes more from top down. And here what we see is that the first wave of API focus, the good old SOA days, they did say that APIs are important, but they ignored the fact that for APIs to be really useful, it's not just important for APIs to be there so that people can use APIs. It's also important that the individual services that are provided by APIs are self-contained, so they can be easily changed, updated, maybe extended, which then leads to a better agility in how I can run my IT infrastructure. And either way, if you have any of those drivers, bottom up or top down, then you might want to go through modernization. But it's really important to think about the reasons. And I think that is something that people always should keep in mind. So typical drivers that we see when we talk to large organizations are an increased focus on business agility, sometimes also designing for change. So that's something where organizations also realize that probably they will undergo changes more frequently than they used to. That's an important observation, and something where you have to make sure that your organization is actually fit enough to be able to change at appropriate cost. The other thing that's also important are these operational complexity concerns. So how quickly, how easily can we adjust changing load? Is that something we can easily do so that we can play around with different models? And then if something works well, we can actually handle it and maybe extend in this direction. And then sometimes it's also compliance and regulatory requirements, where there's the need, for example, to be sure that you can control where certain data resides, because that is part of the regulation, that you cannot just ship around data worldwide. You have to make sure that you can control where it is. So you also have to make sure that you know where this component is running, and maybe you can run it in different regions for different user populations. And this again can be complex when you have a monolithic code base that may make it almost impossible to develop those models of, for example, having different deployment regions for, let's say, for example, user data. So we see all these drivers that come in when we talk about modernization. And one pattern that I want to present today to manage this is called the strangler pattern. So what you see here is a strangler vine. It's a plant that grows around trees and slowly kind of grows around the trees, and over time then completely covers them. And at some point, actually, the trees inside dies and the vine is still standing. And that's the picture of the strangler pattern. The idea being that you grow this increasing set of replacement services around your monolith, and you do that in a strategic way. And at some point, you even may be able to switch off your monolith, maybe not, you'll see. But the main idea really is to go through this process of having this growing set of services around your monolith. And I wanted to walk you through this process very briefly so that you understand what it takes and what the things are to keep in mind. And I've decomposed this process into 13 steps, but these are really easy steps. So bear with me and let's start to go through those steps. So number one, you start with a monolith and you should have some motivation. So you should know why you're even doing this. Don't do it because you feel like doing it. You should have a good goal of why you're doing it, and you should have also a good understanding of which components are the ones that really need to be replaced, because they do create concrete issues. Step two, identify those components and think about capabilities that you can identify where you say, it would be nice if this capability actually was available in a more decoupled way outside of my monolith. So that's the first step where you say, I think about this capability and I think about how I could define those through an API, access it, and ideally it would not be part of my monolith. The next step then, actually carve out this capability, have well-defined boundaries where you say, this is really what I want to do when I talk about this capability. And that is what often you would call a domain. Identify a domain that you want to take, that you want to focus on, and that domain then becomes the domain that you're targeting in this one specific iteration of your process. Next step, understand how this domain actually works in your monolith. In many cases, in almost all cases, this capability in your monolith will also have some shared state. So it will use some database that is part of your monolithic code base. It will share state with other capabilities through these shared databases. This is the part that makes it so hard to modernize monoliths, that there's a lot of implicit coupling in there. But it's important to analyze what this looks like, because otherwise you will never be able to safely migrate those components out of your monolith. This is an important step, and it's important that you identify this shared state that you have in there. Now that you've identified everything that you need to actually realize this capability and to identify those code parts of your monolith that are relevant for it, the next step is to design an API for it. Meaning that now you define an API that allows you to access that capability in a way that is independent of your monolith. So it's an API, and anybody using the API can happily use it. And it doesn't matter whether it's in your monolith or somewhere else. For them, it's an API. So everybody then using this capability can start ignoring the fact that it's, for now, part of your monolith. So you're exposing this capability through an API. Let's move on. Step number 6. Now that you've exposed your API, you also need to manage it. So you need some security around it. Maybe you need some throttling or other kind of access control mechanisms around it. So you probably need some infrastructure for doing that. An API gateway would be a typical component for doing that. So what you start doing now is you start introducing infrastructure that you need for managing this kind of iterative process of creating those components, exposing them, managing them. And then as we move on, we will see how this gateway also serves some other functions. So now that we've exposed the API, people can start using this capability through the API. So they can start using it in an abstracted way. And what I can do is I can start, step number 7, to start re-implementing that capability in a standalone microservice. So now I start recreating my functionality, maybe even in an improved way. But for now, let's just say we're re-implementing it in some other place. And I can do that because I have understood what I'm doing there. I've identified my domains, and I can create a new implementation. Step number 8, I also need to access my microservice. And in order to do that, I should give it the exact same API as my original implementation has. So the API that you see here for both of these service implementations is the same API. That's important. Let's move on to the next step, step number 9. One of the things that is missing in many cases is the state. So my new implementation needs to be able to access data and information that my monolith is managing. And very often that means now I need to start replicating that data to my microservices implementation so that my microservices implementation can use the same data that my original service uses, meaning that now it's not only the same implementation, it also shares the same state. This part can be a little tricky, but it's important because you want this smooth transition, and often it involves some kind of database export and database import or any other actions that you may need to take to move that state from the monolith to the microservice. Once you've done that, you've successfully replicated the functionality and the state. And now you can actually expose the microservice also as something that people can use. So now you have to motivate people to actually switch over. There are sometimes very sophisticated schemes to do that. You can either hard switch everybody, or you can do some kind of traffic switching where some of the traffic goes to the old implementation, some of the traffic goes to the new implementation, and you make sure that always the same things happen. So that's a good way for you to see whether you've actually done well with your re-implementation. But as a general pattern, for a while, you will be managing those two capabilities in parallel, making sure that whatever you re-implement as a microservice actually does implement what you want to implement and works well. Once you're satisfied and you've decided that your new implementation is stable and good enough to focus just on that one implementation, step number 11 is to stop using the monolith implementation completely. So your gateway now only exposes the microservice implementation. And at that point, you are also at a level where you don't need to make sure anymore that you synchronize the state. You might still do it because you're a little unsure. Maybe you have to switch back. But generally speaking, now you're kind of happy with your new implementation. So your next step, number 12, then can be you entirely retire your old implementation in the monolith. You remove any ability to share the state, and you now completely focus just on using the new implementation that is microservices based. What you've done now is you've gone through one iteration of carving out a capability, moving it out of the monolith, making it functional, taking it into production, and moving all traffic to it. And the last step now is not one step, it's many, many steps. Now you just repeat doing that. So as long as there are services that you think would be better implemented as a microservice, you just keep following the same process, meaning that you can carve out more and more pieces out of your monolith. At some point, maybe you can switch it off, but that's really not necessary to decide on whether you want to do this or not. For now, it's just a process where you go through this iteration if you feel like you really need to take one of your capabilities and move it out of the monolith. And this is it. This is the process that I wanted to share with you. To wrap it up, what I wanted to explain to you very briefly is that for this modernization strategy, where you start from a monolith and you want to migrate, the Strangler pattern is a good starting point because it reduces risk. It allows you to do things in a strategic way and an iterative way. So there's no big bang where everything needs to be switched over from one to something else. It allows you to reimagine your capabilities as APIs one by one. So it's, again, a nice iterative approach. And you can do that by focusing on those capabilities that benefit most from modernization. So that's a good thing as well. Don't expect it to be super duper easy. You still need to identify and carve out those domains. That's hard work. It always will be. There's nothing around that. There's nothing that kind of makes that problem go away. So this is something you will always need to tackle. And also make sure that when you build those new microservices, that you don't reintroduce coupling in some shape or form by, for example, starting to use shared libraries across those, or sharing databases, or doing things where you then start introducing coupling again that you just wanted to get rid of. So just be aware of that facet. And what you also don't need to do, in my mind, is from the very start to focus on very sophisticated deployment models. So maybe you don't need or want to use Kubernetes, from the very beginning. Maybe it's good enough that you have a microservices and you're happy with being able to deploy it faster, so that you can make changes more easily and you don't need kind of the sophisticated scaling methods that Kubernetes will give you. So you can be a little bit more, I would say, strategic in terms of deciding what do you want to focus on and what do you want to do maybe later on. And with this, I'm done. Thank you very much for listening. Like I said, my slides are available online. If you want to find them, you can find the URI that I'm showing you here. If you want to find some information about myself, here's some information about my identity on Twitter, YouTube, and LinkedIn. Thank you very much. And with that, I think I can probably move over to Bill again. Okay.
All right, great. Yeah. Thank you, Erik. Excellent presentation. I don't think I've ever seen the monolith to microservices, decoupling in 13 steps like that. That's very useful information in like 20 minutes. That's awesome. And there's so much to dig into. I can imagine like your meetings with clients, like throughout each step of that process, there's it's like very helpful general advice, but I imagine there's so many like
it can still be hard.
And,
yes.
Yeah, exactly. Things to dig into with each step right there. So let's I'm going to table all those questions I have for you for the Q&A. Looking forward to that. And let's bring up Gibson right here to kind of piggyback from your presentation and take it in a new direction. So I'm going to share this for a second. So yeah, very happy to welcome Gibson Nascimento. Gibson is head of solutions for EMEA at Sensedia and is based in Dublin. With over 14 years of experience in software development, agile methodologies, and architecture. He is an expert in APIs and has worked in multiple industries, including retail, pharmaceuticals, health insurance, banking, and some others, to support them changing with their integration approach and API strategy. So in this talk, Gibson's going to explore how trendy technologies like APIs, microservices, and events support legacy enablement and modernization. This is a first-time speaking appearance for Gibson with Nordic APIs, but he's written a couple great articles on our blog about governance and events integration, which I highly recommend you reading. Yeah, I just want to remind viewers to feel free to comment in questions and we'll answer everything after Gibson's talk. So I'm going to stop my share here and without further ado, take it away, Gibson.
Thank you very much.
You're welcome.
Let me share my screen here first. And as always, the classic question, hope you're able to see my screen, right?
Yeah, I see some unread emails though.
Oh my gosh, let me switch. Hold on, let me see. Am I sharing your own screen or not? Okay, you can see the presentation. Oh, okay, sorry.
No worries.
Playing with too much technology makes us crazy sometimes.
Exactly.
Bill, thank you very much for the invitation to join this session today with Erik. It's my pleasure. Like you said, first time presenting here with you. It's very interesting. The topic of today, it's a very trendy one, as you mentioned, and what I want to cover here, it's just, let's say, it's basically a continuation of what Erik has just covered there. So how are the different ways that we can use to then empower our legacy applications. Brief introduction here about myself. I know that you made a great intro there. Not as Erik, as popular as he is, but I'm also speaking in some events, writing some articles. You mentioned both the 2 articles there that I wrote for Nordic APIs. And my main focus, as you mentioned there, it's on helping companies to drive their API strategies, their microservices strategies, and then at the end see the real business value that APIs can bring to them. And I want to start with a statement that, behind most of the apps that we use on a day-to-day basis, although we don't know, most of the times there is a backend application that it's delivering that information that we see in the screen, that is processing something that in the end for us, we don't really know, but a simple message that we see, sometimes it's actually coming from multiple layers and multiple components, right? Meaning that one simple click to book, we don't do that anymore, right? Tickets for cinema, but to order something online, to order food online, it goes through a huge amount of layers and hopes that we can't even imagine, right? So we normally have an API layer that's looking after security. We have internal APIs, just like Erik was saying there, the microservices that are then exposed through the gateway. And then we have the backend, right? We have the application that will, in the end, provide the information or the functionality that we are requesting there. And also on top of everything that we are doing, there's a bunch of other things that are happening, collecting data, social media, things. We don't really realize how many things are involved in this entire journey, right? But then what I want to say is that we still see many companies that are struggling to be able to expose that very important information or functionality that they have at their backend. What exactly that means? It's that they do have some, like if you go to the financial services, for example, they may have multiple functionalities that are written in their mainframes. And although they do want to expose those because those are their core functionalities, they don't have easy ways to do that. Even though they may have all of these layers in place, they may still struggle to get that information, that very important information, out to the customers or to their partners. And why can't they do that? We all know that, and you mentioned something very interesting there, Bill, while you were doing your introduction. Those big monolithic applications, they are self-contained, they're big bunch, big block of code, right? It's very hard to scale. So it's not easy to support all the volumes of the modern applications requirements that are out there at the moment. It's also very hard to maintain, something that you mentioned as well. They are self-contained, so apparently it would be much easier to deploy, but again, they are self-contained. Everything is inside one big block. So if you need to change only one small piece of functionality, you have to deploy the whole application again. Connectivity is another issue that we have. We constantly see that not always it's easy to be able to expose because either the application requires too much re-engineering or because the protocols that the application normally works with are not supported by the modern applications. And another big issue as well is security. We were chatting about this before, right? Technologies change, the problems change, the industries change, but security is always there. So being able to expose data in a secure way, it's something that will, I would say, live forever. And then picking up a legacy, a very old application, you may find companies that have like 10 years old or even older applications that were built back in the days, and they were pretty much satisfying the needs. But exposing that information in a very secure way, it's not that easy. And then the question is, how do we enable a legacy application? Erik mentioned about the Strangling pattern, which is, I would say, a very efficient way to do that. Although I have heard once from a customer saying that struggling, it's a very strong word, that they should change it. But I think that we have very interesting ways to expose the legacy without breaking the business, as you mentioned. I want to touch today how we can leverage microservices, events broker, and then APIs and events. And then by events here, I'm talking about business events, to be able to overcome all of these issues that we mentioned before. and then being able to expose legacy functionalities and data as part of your, let's say, day-to-day modern application world. I want to start from the internal layer, right? So I have split this into two different pieces. One, it's our internal layer. Picking up from the Strangling model, right? Microservices, and I'm mentioning about an event broker here, but it's any queue management system, right? They do help in providing a very reliable, scalable, and secure layer to enable the services that we want to expose. Microservices, I will touch this in the end of the presentation, but starting building microservices on top of your legacy, it's actually the best way that you have to enable your legacy application. You don't need to plan like a big bang approach, replace everything, switch everything off. Not really. You actually build a layer of services that will communicate with your legacy application, and then you start slowly building new microservices, just like Erik said. You plan once and then you repeat. So you start small and then you keep growing your strategy. And why I'm mentioning an event broker there? The events broker, and I could mention a few examples here, but that's not really the point. The main idea of bringing this tool is to be able to support the volumes that the legacy can't really hold. What exactly that means, and I want to switch here. One of the main issues that we've been seeing is back pressure, right? So you build a very interesting and modern API, but then sometimes you forget that at the back end you have a 10 years old application that wasn't designed at all to support 1,000 transactions per second, or a huge peak of 5,000 transactions per second. If you're talking about retails during Black Friday, I would go even above this number. By leveraging an event broker platform, you manage to get information in a queue to be processed in a way that your backend application won't crash. So when we talk about using microservices and events, an events broker, or we could say an event-driven architecture approach, what we'll have are much small deployments. So I can use only, or I can define only a small piece of domain that I want to expose, and then work this out as my overall understanding and maturity of the technology grows. And then being able to, what I used to call fail faster. So you do a small deployment, you test it, it worked, fine. It didn't work, you quickly roll back to the previous version. As an effect of that, you have a very reduced scope, right? So you don't build a big application to then test everything. You can test the small pieces of your application. And when you're using the, like Erik also mentioned, if you are using Kubernetes, for example, you will be able to scale up and down much quicker as well. And then on the events part, so if you're using the events broker, I mentioned the back pressure that you will benefit from it. So we will be able to receive as many transactions as you are able to receive, but then you define the cadence that your backend will receive those requests, and you don't overflow it and crash your backend. You can also get some benefits like SLA management. So you can then identify how you want, or how quickly, or how slowly you want to reply to a certain requests. Again, all coming back to the back pressure, right? So you manage your legacy application in a very, let's say, stable way. And another thing that it's also very interesting and important when you are adopting this approach is the error management. Because if you know, or if you try to get some kind of response from your backend, and your backend isn't available, what you can do, you basically define a strategy to retry that transaction after some time. And basically you are preventing to completely miss some of the requests that you were perhaps planning not to miss. So all of this together gives the basis of the implementation of the legacy enablement. So you start with microservices, very small set of microservices, and then you plug alongside any events or any queue management system to support you to better design the volumes that you can support. And then moving to the next layer, the external layer, it's when we start seeing the benefits, the business benefits of exposing your legacy application. First of all, the APIs that will bring the synchronous pattern, the synchronous communication, the request and response, where you'll be able to expose that microservice that you planned, that ultimately is connecting to your backend as an API. Then you have your consumers, your API users consuming your legacy application directly. And also the event-driven approach, which is a way to move away from the traditional request response style. And you start having consumers that instead of, like I said, are coming to your application every 5 seconds to identify if a new order was created, they can subscribe and receive that information whenever that event really happens. So I used to call this the business moments. The external layer will look after all the security aspects that we mentioned before. We'll make sure that only authorized people will have access to the information or to the functionalities that you're exposing from your legacy application, from both a synchronous and asynchronous communication as well. And what are the things that APIs and an event-driven architecture bring to the legacy enablement? They bring, there's actually much more. I try to bring here just a few benefits that I normally see. It helps companies to define new strategies. So trying to achieve customers that they couldn't achieve before, trying to reach to new markets that they wouldn't be able to do before because they wouldn't be able to expose their legacy applications easily as they can do with APIs and events. It also leverages a lot of innovation. We do see many companies hosting hackathons that bring the community together to come up with new ideas, new apps, or new ways to consume those services that the companies are exposing. It also brings new partners, and by new partners here, this is actually an endless discussion. We can talk from different angles, from different industries. If we're talking retail, and you look at the marketplaces that we have at the moment, right? Amazon, for example, Amazon doesn't really own all the products that they sell, but they have many products that are sold by their partners. If we talk about open banking and the endless possibilities that we have with open banking, that basically a bank can offer one product combining with another, that's called insurance company, for example, and then maybe offer a more specialized product that will identify your expenses, analyze those, and then suggest you or propose a different type of insurance based on your profile. So it brings a lot of new possibilities that are also connected to the new strategies, right? Because you can then start reaching new customers that you couldn't do before. And it also brings new digital experience, right? So if you look at the monolith application, the legacy application that is there sitting on a mainframe or on a big supercomputer, that is only useful within the company's let's call workplace. If you think that there's a lot of value in that information or functionality that you can start exposing to partners, you can consume that in a much better way and then expose different experience to your customers. So either a new mobile app that you can use to nowadays ordering food, like I mentioned, is not something new anymore. Last year we've been doing that for much more than we would, but you can easily achieve new experiences that you wouldn't be able to do before. And a question, how to start this? Erik mentioned something very interesting there, right? So start small. So do define a very specific part of your application that you want to expose. So don't over-engineer. Don't come up with many ideas, many patterns, many technology, a huge technology stack, because in the end, what you want is to validate a proposition, to validate an idea, which is expose your legacy application. With the the growth of the maturity on the technology, on the approach, then for sure you can bring up new elements to it, but do start small and don't over-engineer. And one very important thing, especially when we are talking about microservices, don't worry with the granularity of your microservice at this moment, right? There's an endless discussion as well about microservice, nano services, so how big my microservice should be. If you're just starting, forget about it. Build a microservice that in the end will deliver business value, and that will also enable you to validate this hypothesis. Once, again, you are comfortable with the technology and the approach, then let's call it big microservice that you build can be, again, broken down into small microservices that will then serve very specific functionality of your business. And something very important for me, that's actually top priority, it's understand what are the business goals that you're trying to achieve. There's not really a point, in my opinion, in just following the trendy technologies if you're not following what your business is expecting, or if you're not delivering value to business. Because in the end, doing technology for the technology's sake may be seen from the business angle as just cost. But once we are able to deliver real business value to them, it's actually seen as investment, and then you get the buy-in from the business. I think that was it. I suppose that I managed to be on time. Thank you very much, and open for the questions.
Awesome.
Stop sharing now.
Yeah. Thank you, Gibson.
No problem.
I'm really glad we had you participate in this one, because bringing in the event-driven approach has gotten a lot of track record recently. And I think it's good to talk about that in the whole monolith decoupling microservices journey. So this is great. I'd kind of like to start bringing in your minds together here around the talk of size, as you alluded to, Gibson. But perhaps it's not exactly, how large is the microservice supposed to be, but really it seems like the answer seems to be around the business purpose, right? So it must be fitting into a domain, a specific reusable functionality. So for our viewers, just for their edification and to help them in this process, what would you say are some specific domain examples?
It all depends on the business that you are working, right? So if you're talking about the financial services domain, you have, and again, we can split that into payments, into many things, right?
Yeah.
If we think about payments, right, you could split payments into even smaller domains, right? Like payment initiation could be one domain, payments receiving could be another domain. So how you deal with those domains, but it will always comes back to the domain. If you're talking about retail marketplaces, like I was saying, you could split into orders and then tracking. If you have any perhaps this might sound a bit weird, but batch processing, because you may have like loading of data as well. So you want to load all the products that you sell.
Right.
You don't want to send, if you have 1,000 products, you don't want to send one by one. You can have some kind of batch processing as well. So you could split all of those, like loading, data loading, or something like that. So I suppose that it all depends on the industry that you are working with.
Yeah, that makes sense. It also seems like the beauty of APIs is that you can break things down into those smaller components, like by the method, essentially. So if you need some sort of credit card check, that could be its own method. Some sort of batch processing or ordering, seems like that could fall under like an API method within a larger microservice. Am I understanding it correctly? Maybe Erik, we could get your opinion on how it helps to define a domain. Oh, I think you're muted there. Sorry, yeah. Oh, yeah, it might be those headphones. Something's off.
The issue that we
Just
were
kidding.
chatting
Yeah,
before.
yeah. Maybe that the Bluetooth issue caught up with us.
Okay, well, now it should be no
There we go.
Bluetooth involved. Okay.
Awesome.
Yeah. So domain identification and definition and delineation, right? It's tricky. It always will be, I think. And it's evolving over time, right? It's something where you also might realize that, oh, this is, this turns into a whole discipline, It's like, for example, when you look at like in the financial sector, right? I mean, there used to be very simple risk models, right? Saying that, well, if somebody is, withdrawing more than, I don't know, like $100, let's treat that a little bit differently because it's a higher risk. Right. So that was something simple where you could say, well, that's just kind of a rule of thumb. It's not really a domain. Right. And nowadays, like risk models are so complicated that it definitely is its own domain, right? Like all the data that goes into it, who is it, when does he do it, from where, and all these kind of things, right? So it has evolved, kind of this domain grew, so to speak, to the point where you would say, oh, this is so complicated. We really want to turn it into a thing of its own that we can evolve and manage and so forth. And I think that also explains a little bit what you were saying in terms of the API methods, so to speak, or the capabilities. So as somebody who uses APIs, you don't know how the granularity of the services is, right? So if you, let's say, use 10 endpoints of an API, you don't know whether these 10 endpoints are implemented in one microservice or in 10 microservices.
Right.
And you shouldn't have to know. And it's great that you don't.
I was just going to say that. That should be fully transparent. Yeah.
Yeah, right. So that whoever implements the microservice, they actually over time might decide that, initially it was one microservice, but now we realize that this part becomes so complex, we want to kind of carve it out. So now it's actually a different microservice, right? But you as a consumer, you wouldn't even notice. So as an API consumer, it's the same thing on the web, right? Like if you go to a bunch of websites, you don't know whether these are somehow all hosted in the same place, all run by the same software, or whether these are completely different websites. And you don't care. And you shouldn't have to care. And I think the better you manage this, in the sense that whoever is using services can happily use them, and whoever is providing services, they can arrange them in the best possible way, right? The better you manage to keep those two things separate, the more you keep your options open to change things over time, which will help you to change more quickly, have more options, do all these wonderful things.
Just to add on that, Bill, before I jump off to the next question, I would say that the same applies for the business events. So if you have someone, an application subscribing for an event, so he is interested in learning if an order was created, like I said, or if a payment was initiated, he shouldn't really care if there are 1, 10, or thousands of microservices serving that's that event in the end.
Yeah.
You know, that
Right.
that's indeed the beauty of this. So you hide all of this complexity, and the complexity of building the microservices and managing the queues, it's at your backend, and you
Yep.
manage it the way that best suits the needs of the entire corporation organization.
I really like what you're both saying, you know, because like if you're keeping your options open and you're hiding complexity, that means that the externalized service can change depending on the business needs, and you can like reimagine how you're exposing these layers for developers, especially if we're focusing on hiding complexity. With the great, you know, emphasis on developer experience right now, it seems like that's a really big component.
Yeah, I'm just kind of iterating more on that,
Yeah.
because that's really one of my favorite topics, so to speak, in that space. I think that was really the one big failure of the early SOA days, where people said, you know, SOA is all about exposing APIs, which it is to some extent, right? But they only did that, and they did not really focus on how do we manage the code that is exposing the APIs. And I think when you don't look at that, you're missing out on a lot of potential that is implicit in that whole scenario, but you're not allowing those things to surface because you're still not managing your code well. And I think that is something we've really learned, and that the whole microservices movement has made that very clear, how valuable and important that is. It also has made it clear that it's not trivial, but it also has made clear that there's a lot of value in getting it right. So this is why we see so much investment in that space.
And I even go even further, Erik. You mentioned the backend, right? The code that is managing all of those interfaces. The change in the approach from SOA service to APIs is that we start thinking about how to expose products and not technical integrations only.
Yes.
So the SOA services, they were like a bunch of endpoints doing something. And now we think about exposing products as services. And then again, hiding all the complexities. We can change the backend the way we want. We can change the technology, but the contract that we have with the end consumer, the developers, right? It's always the same. You can change, of course, you evolve, have new versions, but you're still offering the product that has now a new capability, for example.
Yeah. Seems like that's the beauty of API gateways and all these management practices we're talking about right now. You know, being able to generate excellent documentation and have that service definition auto-generated even at times for developers. Maybe we could talk more about that, the role of the gateway. And I'm especially interested in kind of combining your two ideas. Like, where would an event broker be implemented in this strangler pattern? At what point would we start to think about how events are, like, you know, affecting this whole mesh of to-dos?
Yeah, so I mean, I didn't really show any specifics about the API, right? So I would say when the idea originated around the strangler pattern, it was mostly about RESTful APIs, so it would not be eventful things. But in the end, well, that's actually, it's a good point. Maybe I should add that as step 14. You know, like here's what it looks if you want to do events. No, in the end, right? I mean, if you look at events, what events are doing, I mean, they're kind of just reversing the producer-consumer pattern, right? So the API now becomes the kind of the producer of stuff, and the one who is interested in these events becomes the consumer. And they're just waiting, listening for them. And so in my picture, what it would look like is that the API that you would create for this capability that you've identified, that API would take the shape of, let's say, async API, right? It would be a bunch of events where you would say this capability can be represented by exposing those events. And then what you would need to do, which I mean, is just kind of the thing that you always need to do with event-driven approaches, right? You would need to have some infrastructure that is basically your event broker. And that is where you would connect to. And then over time, you would have those events also emerging from your microservices implementation. And that is exactly what what we've heard, right? I think that's what Gibson said is like, you shouldn't know where your events come from. All you do is you listen to your events. And if there's an event that interests you, you say, oh, something happened. So in that event pattern, in the Strangler variation, right, you would also, at some point, your events would start coming from the microservice and not from the monolith implementation anymore. But you wouldn't even notice because, well, it's the same event. So what do I care? So I think, the pattern, I think, works in the exact same way. It's just a different infrastructure that you would put around it. So it wouldn't be your traditional API gateway exposing a RESTful API. Instead, it would be an event broker that would be able to consume these events both from the monolith and from your new implementation.
Yeah, and okay, so if we're just changing out the infrastructure, then it seems like your step-by-step process could remain pretty much intact.
Yeah.
Gibson, any follow-up on that?
No, I think that Erik killed it. It's exactly that. So the Strangler pattern, it's exactly the same. It's just a different way to expose the same service. So you're not exposing it synchronously anymore. It's now asynchronous through the event.
Yep.
That's the main.
Yeah. So the main point really is that the two APIs that you expose in your monolith and that you expose in your microservice, right? These two APIs have to be the same so that you can do the switching easily, right? And in one case, they're both synchronous APIs. In the other case, they're both asynchronous APIs, but they have to be the same.
Yeah. That could be a problem if some legacy applications weren't built asynchronously, I'm guessing. That was one of my follow-up questions for you, Erik. Just how can we ensure that those APIs are identical? That seems difficult.
No, not really.
No? Okay.
Not in principle.
Never mind. We'll just move on.
No, but like first you design the API basically by identifying the capability and deciding this is the API that I want to see for this capability. So that's a design exercise you go through, and that's your decision, right? Like what is the good API for this capability? Then you have to implement that somehow on top of your monolith, either in it or with a wrapper or whatever pattern you need to use with your monolith to actually have APIs somehow exposed from your monolith. That depends on your monolith, right? And then now you know which API you've decided on, and basically that becomes the target API for your microservice to implement.
Right.
Then that microservice really then strictly is an API first exercise. You say, this is the API that I want to implement because I want to go through this Strangler pattern thing. So that is what I'm going to implement. So
I would say that just to complement on that, keeping them the same is just a matter of one thing that many people don't like to hear: governance principles. Making sure that's that you are controlling the versioning, that you're ensuring that they are indeed the same, but this is a governance aspect that you need to make sure that you're implementing as well. And again,
yes, and there's more details in the process, right? So for example, in the design, what you should do is make sure that it's an extensible design so that now if you want to evolve your microservice, you can do that without breaking the API. So, that's another sub-step. But there's more details along the way. Those 13 steps were, like a little glossed over. But there's a lot of experience in doing that. So it's not like, we're venturing into unknown territory. So we're basically doing that all the time.
Indeed. True.
We're adventurers. That's absolutely correct. All this is new, and new best practices are coming out, all the time. So viewers, keep in touch. Follow Erik and Gibson for new thought leadership around, monolith decomposition and microservices and events. This is a great opportunity to kick off some discussion and take back into your teams. So I think we're going to leave it there. Unless there's any, last impressions you want to leave the audience.
Well, like you said, Bill, thanks a lot for hosting, and
course.
thanks, Gibson, for being on the show. It was fun. Yeah, definitely get in touch, everybody. Send feedback. Challenge our assumptions. I think it's really interesting, in particular, to always hear feedback in the form of, yeah, that's nice in principle, but here's what's complicated in my case.
Exactly.
So,
we need more of that. Those kind of real stories.
Yes.
It's super, very informative. It always helps.
Yeah, so thanks a lot for the invite, Bill. Nice show indeed, Erik. Hope to have more of these in the future. And indeed, do follow us. Any questions, more than happy to engage in a conversation, because this is indeed a very long and endless discussion that different experiences may bring new ideas that you never thought before.
Definitely.
So very, very happy to engage in any conversation there.
Yeah, maybe we'll have to do a part 2 in 2021 or 2022.
For sure.
Yeah.
Sure.
We'll keep updated. All right, guys.
Yeah,
thank you so much. I'm just gonna bring up my slides here. We'll do a little outro, and then we'll call it. All right, so this has been another Nordic APIs live cast, and I just want to leave you with some updates from Nordic APIs. If you love APIs and want to share your story, our blog is open for community submissions. You can read our submission guidelines and pitch a topic at nordicapis.com/create-with-us, or follow us at Nordic APIs on Twitter. We also operate a bi-weekly newsletter featuring updates from our writing team, and we're covering many areas in the API space, from general best practices to reviewing new tools, new security tools, and other practices. So you can sign up on the website to always have a little dash of API knowledge in your email inbox. And until it's safe to hold our physical in-person conferences, we're just going to be doing these monthly webinars. So if you have something interesting to share in the coming year, feel free to submit a talk and we'll consider you as a speaker. Hopefully we'll have some more updates on conferences getting into late 2021 and 2022. If you have any questions, feel free to reach out. And as always, thank you to our sponsor, Curity. You can learn more about their OAuth server and identity-driven API security solutions at curity.io. All right, that's it for now. Thank you so much to our speakers, and looking forward to seeing you at another live cast. Thanks.
Thank you.
Thanks
all.
again, Bill. Bye, everybody.
Cheers. Thanks, Bill. Bye-bye.
Bye.